Very happy to be here today. Good afternoon, everyone. So I'm going to be your moderator today with this session, which is called an economic changing area. So we are going to have 6 speakers for the next hour. We are going to keep all the questions for the end of the question. And of course, as Attilio was saying, you can go to the top of your screen to the platform where there is the Slido Q&A, where you can start answering some of the questions which are already there and asked. You can also ask further questions there. So let me also introduce myself. So my name is Laurence Cronier. I'm working at Mercator Océan International. So I'm the head of the market and service department here at Mercator, and Mercator Océan is involved, is developing the Copernicus marine service, and is also involved in the Wikeo Copernicus platform. And as you heard previously, Mercator Océan is also going to be developing the Polar Arctic thematic hub, and is also going to be developing the coastal zone thematic hub. So without waiting much longer, so I would like to start with the first speaker. So Mikko Stralendorf from the Arctic Space Center is going to tell us about the polar services at the Finnish Meteorological Institute. So Mikko has been working in service development related to weather, climate, and Earth observation. So Mikko is currently the Finland's delegate for the EU Space Copernicus Committee. He's also involved in the Group on Earth Observation GEO group, and is also the vice chair of the Sustaining Arctic Observing Network. So please, Mikko, the floor is yours.
Thank you, Laurence, and good afternoon to everyone. Noticing that Marco Mäkynen will actually also be included in this talk, I might have to jump the sea ice a little faster. But just to get quickly to the fact, I have many contributions from my colleagues, and I will also not just talk about the Arctic. There's one slide for the Antarctic as well. So next slide, please. So the Arctic Space Center is really a department of the Finnish Meteorological Institute. It is located in Sodankylä. I was there actually last week, so on Thursday and Friday, have a nice meeting with actually some Sami people and the local fire brigade boss. So we are in the Arctic ourselves, but and interact a lot with the people there. But otherwise, we are doing this kind of like take data from satellites and do something very kind of modern and forward-looking. So we do have some antennas, I think 4 at the moment, 5th coming, and we do a supercomputing system that is processing the received data sets here. So next slide, please. But what we have to talk here is what does it mean, the kind of the Arctic information and the economy changing there. So for Finland, I think the most important thing is that the sea ice in the Baltic Sea is a, or has been for decades or forever in a way, a problem for the Finnish industry, because we are like an island and you have to go through this water that is, let's say, half of the year, at least for several months, frozen at some parts in the Finnish sea areas. And that's why we do have this sea ice service in Finland that uses a lot of SAR or let's say, radar data, let's say quickly. And so we have to do a service where we are actually giving to icebreakers that Finland owns and is operating through a nationally owned company, that these sea routes are still open all year round. And you can see in the top chart that the years are very different. And this difference between the years is the one that is probably changing most in the future. And maybe we might have some kind of especially difficult ice parts. Even if we have little ice, we might have difficult one. But I'm hoping that Marco can give a little bit more detail on those ones. Otherwise, I would say that an interesting thing that we have for the Arctic is our Arctic Now product. So the last one where we are combining both the snow and the sea ice information, because sea ice is the one that gets most kind of global attention, but in effect, the snow situation is more relevant for local people because that's something that comes and goes every year and does a big difference in their business. So next slide, please. So the FMI is very much involved in doing the Copernicus land monitoring services, actually both on global and on European level. So we are doing services in both. Um, so on the one hand, it's snow water equivalent and the northern hemisphere, snow cover extent as well. We have this product in different resolutions. So some are more precise and some are less so. We are talking about kilometers or tens of kilometers, but then we are also involved in production of the high resolution snow and ice product, which started, I think, uh, turn of this year or somewhere early this year only. So there we go even in the kind of resolutions that Sentinel 2 and Sentinel 1 are doing, so 10 and 20 meters. And ESA Snow CCI, so we are also looking at the long-term climate data records, and in the UMETSAT Hydrosat thing, we are also specifically doing snow products that are interesting for the weather service. And this interest comes really that we have many connections where snow especially is interesting for economy in Finland and in northern regions in general. So next slide, please. Before going to those sectors and how we deal with them, also the frozen soil so is something, and if you can put in the there's another click to have the animation going. Okay, that doesn't work. Too bad. Or does it? Try. We have 2017 to 18 how the soil is freezing and thawing. Okay, maybe that doesn't work. So from the SMOS satellite, there's a record from 2010 onwards and still, or let's say, ongoing. That's where we can see also that when the top soil is freezing and when it's thawing. And from this record, you could have seen in this animation quite nicely how the year is very different. And this seasonal change, which is very big, and it doesn't just actually reach, of course, the Arctic. I think many people in Europe, of course, know that there's snow in winter, but the frozen soil is similarly. And these all have an impact on the economy. But let's go to the next slide, and then we can deal with. So one of the most important sectors is, of course, energy production. Anyone at the moment is pretty clear on this when the prices are so high. But for the hydropower production, of course, how much do you have both in snow, as water, as in the water levels of your dam areas? That these are very important factors for production of electricity in northern countries. And we do a specific service with a hydrological forecasting system that we run at FMI. Just check it out. So there's both the land surface model, which also tries to do the soil moisture information, but then stream flow, so to know in which river and which waterway there is how much water going down. And then exactly the most important factor, which has been difficult in past years, is the amount of snow and how much of that will melt at what time of the year. These make a big difference for the business because you can't have more water than the dam allows, but you should try to kind of like more evenly use or produce electricity. So optimizing this is difficult. Next slide, please. Harvest seasons is then the area where the soil moisture or kind of soil freezing thawing is very important. That in Nordic, or at least in Finland, a very important factor is that we have lots of forests. They have to be kind of like environmentally sustainably cut, which is actually best time is in winter when there's either a lot of snow or there's the frozen soil is thick enough that these 20-ton machines can actually operate without kind of compacting the soil beneath and destroying, like for a long time future, that land to be able to grow well trees and other material. So I think this is a wonderful, this kind of like C3S story, because we first of all started with kind of sectoral information for the energy sector, so bioenergy. Then we got to develop this service as a case study, and now we are having this already in discussion with commercial actors to have a specific customized part of this that they want to pay for. And I think it's several thousand, it's 70 millions per year, which is the kind of like difference that can happen in this kind of forestry activity in Finland alone because of the winter situation. So here's a bit the price range that this happens for. Next slide. Forest fire monitoring is obviously something that also now happens more and more, because climate change is kind of like showing us that also the Nordic countries, who so kind of confidently thought that they are taking care of their wildfires fast by being quickly there and distinguishing before it spreads. We now had last summer a situation or last year, a situation in Finland where the fire brigade couldn't for several weeks extinguish this one Kalajoki fire. And I think we have been preparing already before that. We have these kind of satellite data reception at Sodankylä to quickly spot where there's a hot spot. We immediately inform the fire brigades so that they can very quickly get there. But still, we get these fires now that are too difficult to handle, and the whole Arctic has more and more this problem. FMI is now actually involved in the EFIS, in the consortium that will provide for the European EFIS service this fire detection and other products that are needed, for example, for the burnt area. Next. And then quickly, the Antarctic. So as this is a polar workshop, Finland is also a part of the Antarctic Treaty, and we are having an ABOA station. And one of the most important things there was an automatic weather station. And because last kind of a year ago, we couldn't go to the station, this weather station is not working at the moment. So luckily we are going there this year again, and then it will be fixed. But this is an example of how important it is to have in situ stations, and how difficult it is if you cannot get to them, if you cannot handle them, because the winter, at least in the Antarctic, there's so strong winds, so harsh environments that a kind of the instrumentation of a weather station will not kind of be able to handle it all. And we have now been able for about a year to inform weather models and information on this. But this is an interesting thing to also keep in mind. And that was me. Thank you. Next slide. I think it's just the next slide. Is there? Yeah, nothing more. So off to Marco, and if you have questions, put it in the slide.
Thank you very much, Mikko, for this overview of all the activities and services which are being developed in Finland by the Finnish Meteorological Institute. So now we are going to focus actually on some of the services you've been showcasing, and we are going to start by the Baltic Sea. And we have now Marko Mäkinen from the Finnish Meteorological Institute, who is going to tell us about ice services in the Baltic Sea. And actually, this activity received some funding from the Copernicus Marine User Uptake. So Marko, please, the floor is yours.
Yeah, thank you. Yeah, I will present here a short overview about Baltic Baltic Sea ice service that we are running currently here at the FMI. Could you next slide, please? Okay, the acronym for our Baltic Sea ice service is BALFI, which stands for Baltic Sea Landfast Ice Extent and Thickness Service. So we have a web portal that has an access zone here, and there we have a various products on the landfast ice properties, for example, ice extent and thickness. And this BALFI portal and service was developed a few years ago within CMM's user uptake program. Next slide, please. I could start with a little bit of background about the Baltic Sea landfast ice. So every winter there are sea ice in the Baltic Sea and also landfast ice, which means ice that is attached to the coast and islands and doesn't move. That is move not all or very sort of long scale. Okay, I could a little bit explain more within the next slide, please. So here we have an image about the long-term statistic of average landfast ice extent in the Baltic Sea in the late winter here in the March 1st. So every winter there's a landfast ice along the coast of Finland, Sweden, Estonia, Russia, and if there is a very severe winter, there are also landfast ice in the coast of Poland, Germany, and even in the Danish Straits. And this landfast ice, it typically extends from a few hundred meters to even tens of kilometers from the coast. And next slide, please. And this landfast ice in the Baltic Sea, it's sort of a place for many kind of recreational activities. People go skiing on the landfast ice. Here you can see a image of landfast ice last winter at the Helsinki, and there you can see ski marks on the snow. And people go ice fishing, skating. If it's the very smooth ice with no snow, you can even go skating, and then you can go snowmobiling. And also, if it's landfast ice is thick enough, then you can establish ice roads between the land, I mean the coast, between the mainland and islands, and then you can transfer, for example, building materials to your cottage over the sea ice. This is especially very nice if the island doesn't have any piers for large ships to unload your materials, building materials. And also in some places in the Finland, this landfast ice can serve also transport of people from between mainland and the coast. This is especially case for the Hailuoto Island in the Bay of Bothnia. Next slide, please. So within this BALFI, we have a different kind of products on the landfast ice properties. The main one is the landfast ice extent and thickness or ice thickness, and also nose thickness on landfast ice. And then also sort of a qualitative product showing degree of sea ice deformation. And all these products have a 500-meter pixel size, and they are based on Sentinel 1 and RADARSAT-2 radar imagery that we acquired through CMEMS. And also there's a sea ice thickness we use CMEMS Baltic Sea physics analysis and forecast product. And then we take snow thickness from a sea ice thermodynamic model run at the FMI. I guess this Siemens product also has a snow thickness as one of this output, but currently it's not in the output product that is available through Siemens. So the most novel approach that when we are making these products is how to define landfast extent using SAR imagery, and this is based on cross-correlation, calculating daily SAR mosaics, and then we have a SAR mosaics for the 15 consequent days, and then we calculate cross-correlation between these SAR mosaics, and we threshold that and get the extent of landfast ice. So you have a high cross-correlation for the landfast ice that is not moving, and for drift ice you have a very small cross correlation. So the landfast ice extent is sort of a 15 days average extent of the landfast ice. We cannot track very small scale movements, hourly or daily scale movements of the landfast ice currently. And then the snow and sea ice thickness are just taken from the models and mapped over the detected landfast ice, so that's pretty simple. And sea ice deformation, this qualitative product, that's very experimental. It's just also based on the analysis of the SAR imagery. Next slide. So here we have a couple of examples of the Baltic products. Here in the left, there's a sea ice thickness and landfast ice extent a couple of years ago in the Bay of Bothnia. And then there's in the right image, there's this degree of sea ice deformation. That's important if you go, for example, snowmobiling on the snow, on the landfast ice. If the ice is very rich or otherwise deformed, it's very difficult to drive snowmobile on the ice and even to walk on the ice. Next slide, please. So the service portal, we have also the portal to show all these products. And this portal can be accessed with different devices ranging from desktop PCs to smartphones. And the targeted end users, I guess the mainly is just the general public for when they want to go have a recreational activities, they can use our products to see that, okay, what kind of landfast ice there might be in the coast of very near of my cottage or place where I'm living. But it can be also used governmental and local authorities, for example, ice roads management. And we started this service February 2019, and it's active. It has been active since and active during the Baltic Sea ice seasons, which typically last from November, December to May. And here is maybe an interesting topic about, okay, how much they are end users for our portal and products. And this is the statistics for the last winter. So in total, we had around 2,200 users, and at maximum there was 40 users per day. Well, I guess there's a lot of room for improvements, but the last winter was also quite mild in the Baltic Sea. There was mainly significant amount of landfast ice in the Bay of Bothnia. There was quite little in the around Helsinki. And currently, mainly our users come from Finland, 86% of the users, and 10% from the Sweden, and then there are some users from Estonia and some other Baltic Sea countries. And over the half the users has been accessed our service by smartphone, so I guess they are accessing then when they are on the ice or when they are going on the ice. Next slide, please. And here you can see a snapshot about our Balfi portal. So here in the main window, you can select one of the three products of the Balfi products. Here is an example showing the landfast ice thickness. And then you can zoom in out in this window and click some point in the window, and it shows you the location and also the thickness value of the ice. And then in the left side, there are different kind of topics that give sort of more information to the users about our products and our portal and on the landfast ice in the Baltic Sea in the general. And we have made 3 language version of this portal: Finnish, Swedish, and English. Next, please. We also have conducted a little bit validation of the products. So far, mainly, we have compared this landfast ice extent from the SAR imagery processing to the manual ice charts, which are daily products. And there are pretty good correlation between this SAR-based and manual ice charting-based extent on the landfast ice. One interesting observation was that our Balfi products typically have a little bit larger landfast ice extent than the manual ice charts. And when I discussed this with our FMI ice charts people, they said that, okay, this is pretty natural because they are not concentrating analyzing landfast ice extent to the very detailed analysis of land ice extent to all parts of the Baltic Sea. They are mainly concentrating on the areas where there are ship navigation. So they are omitting these sort of a shallow areas and large archipelago areas. Next, please. So there's a lot of topics for further developments. We could show shipping lane information for safety reasons in our products. Optimize the web portal for smartphones. Some users has asked about that from us, and also combine several models for more accurate snow and ice thickness estimation, and to conduct more validation work. Okay, next please, and this will be my final slide. So a couple of years ago, we also made a scientific paper about our Baltic portal and its products, and they are also more about our validation studies. And there's also Siemens UK's sort of a pamphlet about our products and portal. I think I will end my presentation here. Thank you.
Thank you very much, Marco. So I think we are running 10 minutes late, so I will go straight to the next presentation. So we are going to have a presentation by Jakob Belter from Drift and Noise. He's going to tell us about the ICC, a new ice information app for navigation in polar region. So Jakob has been working in many places, and for example, at the Geomar Institute. He's also been working in Svalbard for multiple Arctic geophysics courses. Sorry. He's been a PhD and a postdoc at the Alfred Wegener Institute, and he joined recently the Drift and Noise Polar Services recently in May 2022. So please, Jakob, the floor is yours.
Thank you very much. I think you should be able to hear me. Yes, I'm going to talk about an ice information app, which is based on a lot of data sets that we were able to get from Copernicus. So this is we're sort of users of that kind of data, and we try to pass it on with added value to users out there to sort of use it for whatever purpose they have in polar regions. Next slide, please. I'm going to start and talk a bit about the company that I work for. It's called Drift and Noise Polar Services. We're a fairly small company. It's a company that built from members of the Hpv Sea Ice group, so the Alfred Wegener Institute. It's a spin-off company. So most of us have a background in sea ice. And as I said, I'm going to talk about the ICC app. So we are a software development company, but we're also still involved in consulting and expeditions into the Arctic region, into the polar regions, and we provide navigational support both remotely but also in the field. And we're actively involved in research, which sort of allows us to develop ICC continuously into the future and sort of get cutting edge research into the product that we're providing and add value to the data that we're using. Next slide, please. We already heard about the retreating ice in the Arctic, at least. Antarctic has been sort of not retreating that much in the past years. But anyway, so ice is retreating, and there's growing interest in navigating polar waters. And this is really seen from the kind of clients that we have. So we're involved, you can see it in the top left, in research. So we support research institutes like the Alfred Wegener Institute, the fishing industry, but also the cruise shipping at the bottom left, and the increasing number of cargo operators in polar waters. So this is sort of the client basis that we have, and we anticipate that this is going to increase in the future as more interest in those regions is already generated. Next slide, please. Challenges in this kind of field, especially when you go into polar regions. I don't know how many of you have been there themselves, but it's really difficult to access this large pool of data that you have there. So there's always, being on the ship, there's always the difficulties of organizing the data, how to handle it, but you're also really dependent on the ship's communication system. Do you get the information that you're looking for? You're usually facing low bandwidth connections, so it's really hard to download the data. Then you would go and have to pick up data yourself. Usually there's somewhat impractical regulations on board of these ships, so some web pages that you are not allowed to access, and then considering the time you need to download, data can be old at the time that you get it and you want information from it. Some of the data is not available globally, and it's somewhat difficult to interpret if you're not, into the subject, as, an ice scientist, for example. Next slide, please. Considering all these challenges, it's not really a surprise that most of the navigation screens that we look at on ships in polar regions look like this. So they have the information of the position of the ship, and they have a landmass, and then there's nothing. This is an example of Svalbard. So you probably all know that there's a lot of ice in the area, and there's nothing to be seen on those navigation screens. And this is something that we are trying to change. Next slide, please. I'm going to talk about how we try to do this, and based on the challenges that we have. I already mentioned that it's kind of difficult to pick up all those different types of data that are available. So there's a large pool of data out there, weather data, ice data, talking about ice type, icebergs, thickness, age, drift is a really important thing. But then you also got model data that can forecast drift, for example, or ice conditions itself, and obviously satellite images. And we are trying to use this kind of data and sort of provide a one-stop solution to use all that data in the field and sort of make it into actionable information rather than sitting there downloading everything yourself. You have everything in one place, and this is sort of the goal that we at Drift Noise have. Next slide, please. I'm going to go into one really quick example. Can see an image of I think it's a Russian icebreaker the picture was taken during the Mosaic campaign, and this should give you an idea of what kind of data they use so far for navigation in ice. And this is mainly the ship's radar, and you can see the beams of light in the front of the ship, and this is really the limit, somewhat the limit of how far you can look at this. And on the right side, you can see sort of snapshots of the regions that can be covered with the ship radar. So it's like a range of about 5 nautical miles sometimes. And based on that, you can sort of get your or define the track that you want to take through the ice. And you see the red line there. So you sort of move from snapshot to snapshot to find the best way through the ice. However, when you show the next slide, please. It's always a different approach when you have the entire picture rather than just a really small snapshot of what you can see. So this is a SAR image there, and you can really see that based on the knowledge of the full image, you'd probably select a different path that may look longer on the image right now, but in fact is even shorter because you get to avoid ice flows that are too thick for your ship. You can find open water spaces, and following that, move much faster through the ice than using the ship radar. But in order to do that, you need that kind of information, and you need it through your low bandwidth connection on the ship. So yeah, this is one example. Obviously, there's a couple more, but I'm going to stick with this one for now. And now I want to move on to our one-stop solution, the ICC app. On the next slide, please. This gives you sort of an overview of what you have there. We try to keep it as simple as possible. So the app is a map-based interface where you get to include data sets that are being processed in our backend and provided to the app. And you can see in the top right corner there different layers. So you got sea ice concentration in 6 kilometer and 3 kilometer resolution. You got ice drift information forecast, and most importantly, and really most helpful to me at least, are the radar images that we can upload and you can look at in this app. And the zoomed in version, you can really see individual ice features there. You got ice flows. And speaking of, all the kinds of data that you have, the app's really helping you to have, and I think those are the really important points here, to have everything in one place. So rather than going through different web pages or, different data sources and then processing the data yourself, you have everything pre-processed in one spot. You get the data in near real time. So whenever new data comes in, we process it and make it available. And I think that's the most important part when you go into polar regions with bad internet connection, is all this data is available on demand. So rather than going there and having the website download data constantly, you only get what you actively click on. So if you want the CS concentration updated, you have a little button and you get the newest image, which you get data eight times a day for the CS concentration, and you can click on the individual tiles there. So the radar images are sort of separated into little tiles, and you can download low and high resolution, and you can see that those individual tiles are really small data-wise. So you can really download what you need, where you need it, without having, the best internet connection that you can imagine. And I think those are really important points. Obviously, all of the data that we use is open access, and you can reach it anytime you want, and that's the point, not with a bad internet connection. So this is really adding the value for people that are in those regions and need information for their ships. Next slide, please. I already said that we're not just developing, but we're also part of active research. So the question is, when is ICC finished? I think it's already a really good tool, but we are constantly developing it. So hopefully it's never going to finish. We're really dependent on new data sets that come in that we try to implement so that the user have the best available data for whatever purpose. And we're really in contact with them, going back and forth, getting their feedback, what they like, what they don't like, what they're interested in, and sort of, this is a feedback mechanism that sort of constantly improves the app. And that's the goal. So hopefully it will never be finished, because there's always going to be new data sets available that are of interest. Next slide, please. One of them, and we actually included that last week. Unfortunately, we did that before I had to hand in the presentation. So we included automated ice classification for Sentinel-3 images from one of our partners. So rather than just getting a satellite image, we now also get information of what kind of ice are we looking at. This is a really interesting tool, and I think it's really useful for the purpose of going into the ice. So this is one thing. Another thing that we added was measurement tools. So you can now also measure distances and certain features, like how big is an ice flow, or how far distance do I have to cover to avoid ice, stuff like that. These things are, as I said, things that we constantly develop from the feedback that we get from our users. Next slide, please. Finally, this is a project that I'm currently working on. It's the Fastcast 2 project. And here we're really interested in combining all the kind of information that is available to provide sort of a Google Maps for the polar regions. And obviously Google Maps, when you use it back home in Europe, all the streets are fixed. So you just get information, this is where I am, this is where I want to go. And then you get the fastest or most fuel efficient road. And unfortunately I can't show that here, but the animation in the middle, you can see the different colors that sort of display different ice types, and you have to imagine that this picture is moving constantly. So in terms of Google Maps, it's like you have your streets and they move literally every hour, and you have to adjust for it when you want to get a routing optimized routing for whichever way you want to go. So ultimately, our goal is to provide that kind of Google Maps for moving ice. And this is something that we're currently working on, and yeah, hopefully can implement it into ICC soon as well. Next slide, please. I want to close with sort of a real-world application. I don't know, maybe some of you have heard of it, but in spring this year, the Endurance, the ship of Sir Ernest Shackleton, was found in Antarctica, and Drift Noise was one of the supporters of this expedition. We were on board, and we used ICC, among other things, to really help get the ship into the position where they could find the wreck at the ocean floor. So we've got a lot of really helpful feedback from that, and some of the features that we're looking at to implement are a result of the feedback that we got there in the field with ice pilots. And yeah, that was really impressive expedition, and really happy that we were part of it. And yeah, that was one of the applications of our app. And if you're at all interested, you can, first of all, go check the app out yourself, but also contact us, and we're happy to give you a tour and tell you more about it. Thank you.
Thank you very much, Jakob. So I would like now to welcome Kjetil Melvord. So he's working at the Norwegian Water Resource and Energy Directorate. He's going to tell us about hydropower in Norway. So yesterday we already heard about hydropower production in Iceland, and Mikko a bit earlier was telling us about what's happening in Finland. So let's now hear Kjetil about what's happening in Norway. So Kjetil is a research scientist, and he has a PhD in glaciology from the University of Oslo. And he's been publishing quite a lot of publication, peer-reviewed international publication. And he joined the Norwegian Water Resource and Energy Directorate in 2004. So please, Kjetil, the floor is yours.
Thank you. Thank you for your invitation. I will not talk about, we are now, in the earlier talks we have seen what's happening now, but I will talk a little bit more what we will expect in the future. And I'm not working directly with hydropower by myself, but we are making projection which could be used for hydropower and what they have to do in the long term. So I will talk about the future projection for Hardangerfjorden area. This is the area with a glacier in Norway, and we're using a Hpv model to try to say what will happen in the future with the runoff from the snow and glacier in these areas. This is done with the co-authors you can see on the slides. Next slide, please. Yeah, you can skip this one, the next slide. So when we will make some projection for the future, we need some climate inputs. And of course, we used IPCC AR5, and the research institution has developed the global climate models. And this has been downscaled to regional climate scale in the Eurocordex project. And at NVE, we are doing a bias adjustment of this series in order to use them for hydrological models. And we are running the Hpv model, which has been developed with a glacier parameterization, because we will simulate changes in the glaciers. And then, of course, we will get some hydrological projections. Next slide, please. And here is the Hpv model. I will not go into this detail about these models, but it has a snow storage, it has a glacier storage, and of course it has something about forest and landscapes, and it also has some soil transport and also groundwater transport in this. And it's all could be routed out into lakes or rivers from different areas. The glacial model is has a source by as a model which is developed by Matthias Huss in 2010 and others. So you can look it up if you want. Next slide, please. Next slide. Yes, I will skip one now. Should be another one first. The other way. Go. We are going the wrong way now. It should be. Yes, we need some input data, and for this input data, we use we need the glacier geometries, and this is an example how we use satellite data for taking out glacier extents. So on the left side, you can see glacier-derived polygons for different years of the glacier extent. And on the right-hand side, you can see the Sentinel-2 image, which is the base for the 2019 outlines. And you can see the glacier as blue, and the white is the still snow-covered areas. This is taken in August, these pictures. So we need these Sentinel images or the satellite-derived data when we should initiate our hydrologic model, we need some known glacier extents, because then we can calibrate the model to run for what we have been seen or what's had happened in the past. We take the next slide, please. We also need some surface topography, and we also need bedrock topography. So on the left side, we see the surface, and on the right-hand side, we see the bedrock topography beneath the glaciers. Next slide, please. And of course, we need some forcing, and in the Hpv model is using the forcing is the temperature and precipitation. And this example is from if you use the RCP 8.5. This is you can see how the temperature is changed for 3 of these regional climate models and different. And you can see that there is quite large changes in the area. It's more than 6 to 8 degrees of temperature change. So we have minus degrees today, but in the future maybe we get annual plus temperature, and we can also see large changes in temperature. But there is a large width of possibilities with this model because we use lots of them. And we take the next slides. And here we can see how the area will be changed in the future until 2100. The red areas is the glacier area in 2100. And on the left side, we have RCP 2.6, and you can see that the glacier is quite large still. But if you look at the right-hand pictures, the RCP 8.5, you can see that's only small part is left in 2100 if the climate projections. So we take the next one. And this will, of course, affect the runoff from the glaciers. So here we can see that the annual runoff has already started to increase. And into the future, it will still increase until the glacier area gets less, and then it will decrease again. So, but the peak discharge will depending on the climate projection. So the peak will come relatively fast if we used RCP 2.6, but if you use the RCP 8.5, it will come to the next, say 2049 or middle of this century. So, so the peak will be coming before the maximum temperature because the area is decreasing. The next slide, please. But this will also affect the runoff, the daily runoff. And this is maybe very important for the hydropowers. So if we look at the the graph on the right-hand side, we can see the red curve is what we have today. We have a very strong seasonal signal. We have more or less no snow during the winter when it's snow-covered and it's cold in this area. And also in the late autumn, it's very small. But in the future, we can see the blue curves that we will have a lot, the peak in winter time will be much less than it will be much larger runoff in the winter time, and the peak during summer will be much less. So this is due to less glaciers melt and also less snow melt. And also in the autumn, we have a long tail of melt, which we don't have today. And we can see this is also for the areas without glacier on the right-hand side. We can see that we get a lot of runoff during winter because we don't get any more snow or less snow, and we get rain, and that will feed the reservoirs. So this will affect the hydropower production plants, because today we have to keep water in the reservoirs during the winter, from the summer melt in the reservoirs to use in the winter. But in the future, we maybe get more water during winter, and we can use it. But at the same time, we may get some problems during summer if we use too much. So we take the next slide. So to conclude, the amount of snow and glacier melt will decrease in the later part of the century, and this will have large effects on the seasonal runoff, and it will also affect hydropower production and planning. So it will be more. So we have to have a new way of thinking about the hydropower production in the future. Thank you very much.
Thank you very much, Kjetil. So now I'm very happy to welcome Anders Persson from the Swedish Forest Agency. So Anders is going to tell us about forestry services developed in Sweden. So Anders holds a Master of Science in Forestry. He's been involved in many forest and remote sensing projects in Sweden. And he started his career at the Swedish Space Cooperation, and he's now been working at the Swedish Forest Agency for the last 26 years. So please, Anders, the floor is yours.
Thank you. Thank you for letting me speak about this. You can take next slide. You know that the Copernicus satellites gives us a lot of new opportunity. Copernicus is really a game changer for Swedish forestry. Almost daily data we get from it, and we can use it for many applications. I will focus on the change detection. We are using Sentinel 2 we use that to follow up clear fellings in Sweden, in the whole country. But we are also using the same technique, the change detection technique, to map areas of spruce bark beetle outbreaks, which has happened a lot now since the climate is warmer, and we also see a lot more forest fires, and we use the same technique for this. So next slide. We use satellite data since many years, but we are nowadays able to use it almost daily. Previously, we used annual images of mosaics covering the whole country with data from Landsat Spot, IRS, and one of the last years from Sentinel 2 as well. But we were not able to follow up that more than once a year. But nowadays we can use a time series analysis using Sentinel 2. So next slide, please. With the two satellites, A and B from Sentinel 2, we get data almost every day, and you can see in the picture that if we get data on Monday, we won't get it on Tuesday, but maybe on Wednesday and Thursday, but not on Friday, and etc. So this gives us a good opportunity to follow up things that happen in the forest almost daily. But there are, of course, a lot of clouds that gives us bad pictures. But in the long range, we get a lot more images than we could have before. So next slide. We are using data from the Copernicus DSS. We are actually, or more specifically, using data from Mundi, and we are downloading that kind of data every day. We project it to the Swedish coordinate system, create a mosaic of images covering the whole country, and update our web services with that and serve it out to our users. And the users are not only ourselves, but also a lot of forest owners and forest companies in Sweden. So they use the same data as we do. So next slide, please. And we are going from, as I said, we are going from updates yearly updates to only monthly updates or weekly updates. This gives us a good opportunity to have a much quicker response and faster feedback to our own personnel, but also to forest owners themselves. A lot of forest owners are actually living in big cities like Stockholm, but have their forests far away, maybe in the far north of Sweden. And by using the services from Copernicus, they can actually follow on almost a daily basis what's happening in the forest when they have cutting machines doing some kind of clear cutting there. But it also gives us, our personnel, better feedback so that we can follow up misuse of the forest land. We can also follow up damages done by the machines much quicker and come back to the machine owners and help them make better treatment next time. So next slide, please. So on the diagram to the left, you can see a time series of an area that has been notified to the Swedish Forest Agency. And the diagram to the left shows an area that has not been harvested yet. All the blue dots are actually images and the pixel values in the shortwave infrared band. And the pixel values are accumulated, so we get a nice almost straight line if there is no harvested done. But if you look to the right, you can see that after some time, this straight, almost straight line with blue dots is changing direction, and that's when the area has been harvested. So we are looking at the statistics of the area and look for this change in the curve, and that's where the clear cutting has occurred. And if we get 3 significant changes in a row, we conclude that there is a clear cutting. So you can take next slide, please. Here is an example of the same area in the right-hand diagram in the previous slide. And you can see in June 3rd, there was nothing, there was no cut has been done, but on June 13th, you can see they have started the clear cutting. June 15th continued, and in June 25th, you can see that they are all done. And next slide. So when we have that kind of information, we can easily make a change detection showing those pixels where all the changes have occurred and threshold that and create a polygon, add metadata to that and publish that to our system, which is also available to the forest owners in Sweden. So, and this kind of process is automatic and done on the fly every day for all cuttings in Sweden right now. So next slide. And we have a queue-based system right now that is making all these changes and polygonizing and analysis on the fly, and we can easily follow up if any errors occur. So I think that was my last slide. So next slide, I think there's a thank you.
Thank you very much, Kjetil. Anders, sorry, I think we are catching up a bit on the delay that we have. So the last speaker today is Andreas A. Kaljord from KSAT, and Andreas is going to tell us about oil spill services and maritime traffic services, which have been developed by the KSAT company. So please, Andreas, the floor is yours.
Thank you very much for the introduction, and good afternoon, everybody. So in my presentation, I will talk about what KSAT does with regards to maritime and environmental monitoring, and of course with a special focus on the activities we do in the polar regions. Just to start off with a few words to introduce KSAT. KSAT is a Norwegian company based in the Arctic in the north of Norway, with headquarters in Tromsø, where I'm currently at 69 degrees north. So we are approximately 400 kilometers north of the Arctic Circle. We are a leading provider of satellite ground station and Earth observation services with offices in Tromsø, Svalbard, Stockholm, and Colorado in the US. In total, we are now around 300 employees. And KSAT has a history going back more than 50 years, actually, as a satellite ground station here in Tromsø, and that was basically since the start of the space age in Europe, when Tromsø telemetry station, as it was called then, received the first signals from Europe's first satellite, which was SRO-2 in 1968. Next slide, please. So working mainly with polar orbiting satellites, higher latitudes means that you are able to communicate with the satellites more often, of course. This more often means faster access to the data and imagery acquired by the satellites. We have our own back, please. Switching a bit fast. If you go back one, yeah. So we have the main operations in the Arctic, especially in Svalbard, but we have a global ground station network consisting of more than 270 antennas at all these 26 locations. And you can also notice this Antarctica TrollSat station where we have at least 10 antennas. Next, please. So to go a bit more into detail about Svalbard and the station there, we have KSAT established this station, and it's actually now the world's largest commercial ground station called Svalsat at Svalbard. So this is 78 degrees latitude. It's approximately 1,300 kilometers directly north of the Arctic Circle. And we have more than 100 antennas that receive data and communicate with satellites from all the major satellite operators. It was established in the late 1990s. Then there was nothing there on top of this plateau mountain at 400 meters altitude. So the growth has been quite amazing. And actually this picture in this slide is probably 4 years old. So it's grown even more since then. The picture in the lower left shows the downlink cone of Svalsat. So the main point in that picture is that the cone covers all the 14 daily passes of a polar orbiting satellite, and that's actually the only ground station in the world where you cover all 14 out of 14 passes. Next, please. So in KSAT, we have 3 main business areas: the ground network department, which provides services to satellite owners in the different stages of satellite life cycle, all the way from launch to regular operations. The Earth observation department, which I work for, and this slide shows details what we do in that department. And also the government programs department, which in addition to Earth observation is involved with satellite operations, such as mission control and payload ground segments. Satellite Earth observation can be valuable, as you know, for a variety of applications. from environmental monitoring, such as pollution detection, vessel traffic and IUU fishing, to applications related to, for instance, mapping and security. In KSAT, we provide operational services for vessel detection, oil spill detection, and also for sea ice monitoring. From our perspective in the Earth Observation Department, we focus on getting the relevant information to the end user as fast as possible, and also with the sufficient or right level of detail, so that we can provide what we call actionable information to the end users. So I will go a bit more into detail about the satellite oil spill detection, vessel detection, and near real-time data provisioning services in the rest of the presentation, since these are the most relevant topics for the polar region. Our satellite oil spill detection service is mainly based on SAR, synthetic aperture radar. As many of you, I think, know by now, the big benefit of SAR is its ability to see through clouds and darkness, which is especially important in the high north, where we have the low light conditions for at least half the year, and in general we have quite a lot of clouds. And SAR has been proven to be an excellent sensor to detect oil slicks on the sea surface, since the backscatter from the sea surface is clearly visible and heavily affected by the oil slicks, and dampens these small capillary waves on the sea surface. We have actually seen confirmed oil spills as low as 40 liters, and so-called produced water from oil platforms with as low as 4 parts per million concentration of oil. The detectability, of course, depends on the wind conditions, and too low or high wind will affect what we can see in the imagery. So the image on the right shows an example of how it looks in real life. The yellow lines is pipelines that we have put on top, and of course the dark area is the oil slick. Next, please. So this is a historical outline of the kind of history of the satellite oil spill detection service. In Norway, we have used SAR satellites since the early 1990s to monitor Norwegian waters for pollution. The service was first started off as a research project in cooperation with the Norwegian Defence Research Establishment, the Norwegian Environmental Agency, and KSAT. In the early 2000s, the service was expanded to several European countries, and more satellites was included in the services. And the information could also be received by more users. In 2007, the European Maritime Safety Agency, or EMSA, established the Clean Sea Net service, which is an oil spill and vessel detection service offered to all European countries. And KSAT has been an important service provider into Clean Sea Net since the start. In 2016, the Norwegian oil company Equinor applied to the Norwegian Environmental Agency to use satellites to monitor oil assets for oil spill, and use satellites to prove to the regulators in Norway that the operations were clean and didn't pollute. This led to the start of the daily monitoring of all oil assets on the Norwegian continental shelf. And more recently, the service has been expanded both with regards to frequency, i.e. we have increased from 1 per day to 2 per day in some areas, and also we have expanded the areas that we cover. Yeah, next slide, please. SAR is also an excellent sensor for vessel detection, of course. Again, the ability to cover huge area and also to see through clouds and darkness is the most important benefits. An important part of the vessel detection service is the correlation with ancillary information sources, such as satellite or terrestrial AIS. And more recently, of course, the satellite-based RF source detection is getting more important. In these images, you can see the color coding of the detections The green targets are SAR detections that have been correlated with AIS. Blue targets are AIS targets only, so it can be either be, for instance, a too small vessel for it to be detected in the SAR image. It can also be fishing equipment, which has been equipped with an AIS transponder. Or as you can see also, it can be vessels outside the SAR image, so then obviously it will not be detected in the SAR image. The red targets are the detections that are only detected in the SAR image. They are not transmitting AIS information for some reason. And then we can call them dark targets, and they are typically of special interest for enforcement authorities. And this information can contribute significantly to more efficient use of surveillance assets, such as Coast Guard vessels and aircraft surveillance. We also have a long history in providing operational satellite-based vessel detection, going back more than 25 years. The main applications of vessel detection are, of course, fisheries control, IUU fishing, and environmental monitoring and pollution control, security, and in general, national domain and activity awareness. In the Arctic region, we deliver vessel detections to EMSA, Norwegian public agencies, and the Barents Watch portal, which is an information portal for the Norwegian coastal and marine areas. The vessel detection from SAR is normally also part of our oil spill detection service, since vessel activity in general is an important potential source of pollution. Next, please. In addition to the oil spill and vessel detection services, we also provide near real-time satellite imagery, both SAR and optical, to various activities in the Arctic. In southwest Greenland, we have been providing the near real-time SAR imagery service for nearshore ice charting to the Danish Ice Service since 2017, when the Danes replaced helicopter-based ice monitoring with satellite SAR imagery. This service has actually only been based on TerraSRX or PASS data. We have also been involved in various projects related to vessel traffic in or near ice. For vessel navigating in ice, as was shown in the previous presentation, it can be a huge benefit to have access to updated satellite information to be able to find the optimal routes in the ice, and also with regards to safety. We are also providing an operational iceberg detection service that is quite similar to the vessel detection service. Yeah, next, please. This slide is just to highlight the most important functions or requirements that applies to all the satellite-based services that we provide at KSAT. I think especially the first bubble, the good planning and order handling, is an extremely important aspect of EO services that is very often left out of the service. You of course need to be able to task the satellites on different timescales, but in my experience also good feasibility studies and advanced planning is essential for the success and effectiveness of a satellite monitoring program. Depending on the needed temporal and spatial frequency, you will most often need to use different satellites. And of course, if the services are time critical, you need to have 24/7, 365 operations that can ensure the rapid analysis and delivery. Next slide, please. Yeah, these are the SAR satellites that we use in our services. We basically use all the SAR satellites, both commercial and non-commercial. And we downlink the data ourselves, and we can also process them in-house. Yeah, next, please. These are the ground stations that we use for Earth observation in Europe. Svalsat in the high north is part of the Copernicus core ground segment, but we also use Tromsø, which is part of the Copernicus collaborative grant segment. And we have also started to use Portuano in Spain and EMEA in Greece. So overall, we have a quite nice coverage for all of Europe, and we, for instance, we can listen in on all the Sentinel-1 data downlink within these cones, and we can process it ourselves and deliver it in a few minutes after acquisition. Next, please. Yeah, I mentioned the daily monitoring of the oil and gas assets on the Norwegian continental shelf. It's a cooperative model that makes sense since each satellite image can cover up to 500 by 500 kilometers. So all the operators cooperate on managing this service. And this was the industry themselves, the oil and gas industry themselves decided that this was the best available technology to use to prove that they are not polluting. Yeah, next please. As mentioned, we deliver oil spill detection and vessel detection to EMSA and to Clean CNET, and they make the service available for all the member states and authorities in the EU and EEC. EMSA is also the responsible entity for implementing the Copernicus Maritime Surveillance Service. And the CMS service provides satellite imagery and services to monitor human activity at sea for a range of applications. Yeah, next please. Finally, I just wanted to mention the other new European initiatives that KSAT is currently working on. So we are part of the new Symphony Consortium, also the ESA-funded Arctic Weather Satellite, and the Norwegian MicroSAR initiative, which aims at launching SAR satellites specifically designed for maritime domain awareness. And that's led by Space Norway. And HEOSAT satellites designed to enable broadband communication in the Arctic. And also this ESA Moonlight initiative, which is defining a system for lunar telecommunication and navigation solutions. Yeah, I guess I went a bit over time. That was my last slide, I believe. Thank you for your attention.
Thank you very much, Andreas. So indeed, we are running slightly late. So I'm going to ask all the speakers to turn on their camera. And by that, I'm going to warmly thank all the speakers. I think we've had a very nice session showcasing all the economic activities which are being currently developed in the polar area, in the Arctic region. So I'm really sorry we have no time for questions. We are going to have a 1-minute coffee break. And we are going to resume within the next 1 minute actually for the startup pitches. So no time for questions, but thank you again and talk to you soon. Thank you. Bye-bye.
Thank you.